When we talked about the admissions data example, we were looking at the mean SAT score, as well as the proportion of students needing dorm housing. We will now consider how the sampling distribution applies to proportions. Remember, a proportion from a population is that decimal fraction or percentage that satisfies some property. Much as we can make inference about a population mean, we can also use a sample proportion to make inference about a population proportion. And as with the mean, the expected value of the sampling distribution of proportions, P bar, will be equal to the population proportion. The formula for the standard deviation of the sampling distribution of proportions is slightly different from the formula for sampling distribution of the means. We designate this standard error for the proportion as sigma sub P bar, where P equals the population proportion. And as with the means, there is a correction factor if we have a finite population. The sampling distribution of the proportion can be approximated by a normal distribution, as long as the sample size is large enough, measured by the simple ratio formula. Let's go back to our admissions example. Remember that the proportion from the population was 0.72, or 72% needing campus dorms. What is the probability that a sample of 30 will yield a sample proportion that is within plus or minus 0.05 of the population proportion? Testing this example, we see that given N and P, we satisfy the rule that our sampling distribution of the proportion will be a normal distribution. And the distribution will have a mean equal to the population proportion of 0.72. We calculate the standard deviation of this sampling distribution of the proportions, and that standard deviation, also called the standard error of the proportion, we calculate that to be 0.082. Using the z distribution, we can now calculate the probability of being in that interval of 0.72 plus or minus 0.05, or 0.67 to 0.77. First, we calculate the z value for the upper limit of 0.77. And from that z value, we'll find the area to the curve to the left of that as 0.7291. Using the table, you can see how we found that probability. And that's shown in this sketch of the normal curve. We repeat the same process for the lower limit of 0.67. Find the z value, find the probability to the left of that z value. Again, shown in this sketch. The area, or the probability between those two z values, and therefore in our interval around the population proportion, is 0.4582, approximately 46%. Therefore, we conclude that there is a 46% probability that any sample will have a proportion within plus or minus 0.05 of the population proportion. In other words, between 0.67 and 0.77.